Good morning everyone. In this video, we are going to discuss the solutions to the problems I presented. The first problem is finding the last two digits of 41 to the power of 86. How to find the last two digits of 41 to the power of 86? Put the last digit as 1 and multiply the second last digit of the number below with the last digit of the exponent. Put the last digit as 1 and multiply the second last digit of the number below with the last digit of the exponent. 1 is the last digit and the second last digit is obtained by multiplying 4 with 6. 4 into 6 is 24. The last digit is 41. The second last digit is 4. So the last digit of 41 to the power of 86 is 41. Now let us look at the second problem. The second problem is what is the remainder obtained when 73 to the power of 67 is divided by 100. This is same as finding the last two digits of 73 to the power of 67. How to find the last two digits of 73 to the power of 67? Remember the power cycle of 3. The power cycle of 3 is 3971. Express 73 to the power of 67 as 73 to the power of 4 into something, 73 to the power of 4 to the power of something into some number and solve it. Now 73 to the power of 67 is 73 to the power of 4, the whole power of 16 into 73 cube. 73 to the power of 4, the whole power of 16. Now let us just consider 73 to the power of 4, the whole power of 16. This is same as 73 square into 73 square, the whole power of 16 into 73 cube. 73 square is 50 plus 23 square. So the last two digits of 73 square will be affected only by the last two digits of 23 square. The last two digits of 23 square is 529. So the last two digits of 23 square is 29. Now we are having 29 square, the whole power of 16 into 73 cube. 29 square, the last two digits of 29 square is nothing but the last two digits of 21 square. And 21 square is 441. The last two digits of which is 41. So finding the last two digits of 73 to the power of 67 becomes finding the last two digits of 41 to the power of 16 into 73 cube. What is the last two digits of 41 to the power of 16? 1, and 41 is the last two digits of 41 to the power of 16. So this problem becomes 73 to the power of 67 becomes finding the last two digits of 41 into 73 cube. Now 73 cube can be divided into 73 square into 70, can be separated into 73 square into 73, 73 square into 73. Now we know the last two digits of 73 square, which is the last two digits of 23 square, which is 29. 23 square is 529, the last two digits of which is 29. So this becomes 41 into 29 into 73. There is no short way to find the last two digits of 41 into 29 into 73. We have to multiply and find it. Let us take 29 into 41. 1 into 29 is 29. 4 into 9 is 36. This is enough. 9, 8, 89. So the last two digits of 41 into 29 is 89. We have to multiply this. So 3 into 9 is 7, 27. 3 8 is 24, 25, 26. 7 into 9 is 63. So 97. 97 is the last two digits of 73 to the power of 67. 97 is the last two digits of 73 to the power of 67. Now let us look at the third problem. The third problem is finding the last two digits of 85 to the power of 86. Finding the last two digits of 85 to the power of 86. The problem is given as find the remainder when 85 to the power of 86 is divided by 100. This is same as finding the last two digits of 85 to the power of 86. How do we find the last two digits of 85 to the power of 86? Take 85. 85 to the power of 1 is 85. 85 square. 85 square is same as 100 minus 15 square. 15 square is 225. The last two digits of it is 25. Now we have 85 cube. 85 cube is 25 into 85. The last two digits of 85 cube is 25 into 85. 25 is 125. 25 8 is 200. So it ends with 25. 85 cube also ends with 25. So we know that 85 raised to any number will end with 25 only. So 85 to the power of 86 will end with 25. This is how we solve the problem. And now let us look at the fourth problem. The fourth problem is finding the is like this. To find the remainder of 67 to the power of 83 when divided by 25. For this, again we have to find the last two digits and divided by 25. It is simpler this way. Instead of using Fermat's theorem and all that, we can find the last two digits and divided by 25. One second. One more thing which we need to remember is, if it is division by any number like 100, 50, 25, 20 and 4, we just need to find the last two digits. Why is this working? 100 is 2 square into 5 square. And 50, 25, 24 are all 22 into 5 square or 2 square into 5, 2 into 5, etc. It works also for 10. For 10, we can just find the last digits itself, instead of finding the last two digits. Let us take 67 to the power of 83. The power cycle of 7 is 7, 9, 3, 1. 67 to the power of 83 is nothing but 67 to the power of 4 to the power of 20 into 67 cube. 67 to the power of 4 is nothing but 67 square into 67 square, which is nothing but 17 square into 17 square, which is nothing but 89 into 89, which is nothing but 11 square, which is 121. The last two digits of it is 21. So 21 to the power of 20 into 67 cube. 21 to the last two digits of 21 to the power of 20 is 101. So finding the last two digits of 67 to the power of 83 becomes as simple as finding the last two digits of 67 cube. 67 cube is nothing but 67 square into 67. 67 square is nothing but 17 square, which is 89. So 89 into 67. Finding the last two digits of 89 to the power 89 into 67. We need to find the last two digits of 89 into 67. Let us find it. 7 9s are 63. 7 8s are 56. 62. 23. 6 9s are 54. 4 and 5. 63 is the last two digits of 67 to the power of 83. 63 when divided by 25 will give the remainder. Sorry. I guess this problem is clear. Let us solve the next problem. 79 to the power of 24 when divided by 4. We need to find the remainder when 79 to the power of 24 is divided by 4. 79 to the power of 24 is nothing but 79 square, the whole power of 12. And 79 square is nothing but 100 minus 21 the whole square. 100 minus 79 square, the last two digits of 79 square will be affected only by 21 square. So 21 square is 441, the last two digits is 41. So 41 to the power of 12, which is 81. So 81 when divided by 4 will give the remainder 1. So 1 is the answer for the last problem. I guess all the problems are clear, and we will deal with the last two digits of numbers ending with 2, 4, 6, 8, 10, etc. 2, 4, 6, 8, 0, etc. in the next video. Thank you.